This is the video lecture for the Properties of Water content page. Now for this video, I don't want you to take notes on separate loose leaf paper. I'd like you, as the directions say, go to the resource table and get the Properties of Water note sheet. It looks like this. We're going to fill out this box, and this box. These top three boxes here. Now we're learning about the hydrosphere, or water, all the water stuff on Earth. Water is essential for life as we know it, and the Earth has tons and tons of water, and it's a very special molecule, a very special liquid. The properties of this molecule have enabled life to not only emerge and evolve, but to survive, thrive, and prosper. So the first property is polar. But let's just talk about water a little bit and what it is. People say, and you all know, that water is H2O. It's a little bit of chemistry, and I know you haven't had that, so I'm going to simplify this. Some people think that this means that there's one hydrogen and two oxygens, but they are incorrect. The subscript here goes with the element right before it. So what this actually means is that there are two hydrogens, and there's one oxygen, H2, two H's, and an O. Now, when you learn chemistry, you'll learn that there's some different shapes that molecules can take, but I'm just going to show you what water is. Oxygen, which is a much larger atom than hydrogen, is in the center. And then we have these slightly slanted single bonds. This is a chemical bond where the oxygen is bonded with hydrogen on one side and hydrogen on the other side. That's H2, two H's, and one O. Okay? Now let's remember something from a little while ago. This is from, I think, like our second content page of the year. We learned about what atoms are when we were learning about the atoms of the universe. And we learned that there's protons and neutrons in the center, in the nucleus, and there are electrons flowing around it. The protons are positive, the electrons are negative, and they kind of balance each other out. The positive charges are balanced out by the negatives of the electron. But what's cool about these electrons is that they can be shared between different atoms. So if you could picture this, the electrons, I'm just going to draw like one, are floating around, getting attracted by the nucleus of the hydrogen, the one proton, and the nucleus of the oxygen. They're getting shared. That's how they bond together. They're sharing electrons. It's called covalent. You'll learn more about that in chemistry. But what's cool, or I should say very unique about water, if we look here, water is very small, 1 AMU, the mass. Oxygen is 16. It's a lot bigger. So oxygen actually has a bunch more, or a lot more, protons in the middle. So it has much more positive charge. So what that does is actually the oxygen sort of hogs up the electrons. They still flow around the H's, but they kind of like to hang out around the oxygen a little bit more because it has more of a positive charge. Now what that does, since oxygen has a more attraction to the electrons, there's more negatively charged electrons around the oxygen, so it gets like this negative, sort of partial negative charge. And since the hydrogens are sort of losing the electrons, they don't have them as much, they get a more positive charge. Now this is called a polar molecule. Polar, like think of the Earth, right? The Earth has a North Pole and a South Pole. It's polar, it has two separate sides. That's what this means. Polar means that there's two different charges on here, a more positive side and a more negative side. Now that does a lot of cool things for water. Make sure you draw and label the molecule here, and what polar means right here. But what that enables to happen, as you'll see in your content page, is that water likes to bond with things, and it makes what are called hydrogen bonds. These are relatively weak bonds, but if there's enough of them, they can really hold things together, they can dissolve things, and they can give the other properties of water. All of the properties of water are based on this polarity of water. All right? I'll erase that later. For example, let's say you have one little molecule of water and you have another molecule of water close to it. What will happen is that the more positive hydrogens will form these weak hydrogen bonds with the O, and the O will form they bond with the other H. And this can happen in a huge, big, huge bonding mess. These, although they are weak bonds, they can do crazy things with water. For example, they can make water have a high specific heat capacity. They can make it dissolve things, universal solvent, and can make it stick to itself, but also stick to other things. If you've ever seen like water beads falling down a window, you can have water drips on a window that don't actually slide down. They're fighting gravity because they're actually sticking to that window. They're adhesive to it. High specific heat capacity means that it can hold a lot of energy. Since water can make these hydrogen bonds with other water molecules, it takes a lot of heat, a lot of energy to break them all to make water change phase. So water on Earth is a really good buffer for temperature because it's able to absorb energy really well. That way, if a place gets a lot of sun directly, if there's water around, it can kind of keep the temperature kind of mild. It'll keep it more stable.